Introduction. Analytical chemists have a few tools as powerful as natural process to measure distinct analytes in advanced samples. The ability of natural process comes from its ability to separate a mix of compounds or analytes and determine their several identity chemical structure and concentration. Chromatography is divided into three basic sorts that embrace gas, liquids, and critical fluids natural process. Liquid natural process will more be divided into natural action, separation, supported size, and even extended into gel-based natural action techniques. All chromatographic systems have a mobile phase that transport the analytes through the column and a stationary phase coated onto the column or on the resin beads in the column. The stationary phase loosely interacts with each analyte based on its chemical structure, resulting the separation of each analyte as a function of time spent in the separation column. The instrumentation for gas chromatography are: number 1, flame ionization detector, or FID. A flame ionization detector is a scientific instrument that measures analyte in a gas stream. Number 2, an electron capture detector, ECD, which is a device for detecting atoms and molecules in a gas through the attachment of electrons via electron capture ionization. And number 3, the thermal conductivity detector, or TCD. This detector senses changes in the thermal conductivity of the column effluent and compares it to a reference flow of carrier gas.
And now we proceed to the methodology for this experiment. Before we run the experiment, we have to prepare the apparatus and the chemical. The apparatus that we need to run this experiment is the syringe, beaker, and the dropper. For the chemical, we use the acetaldehyde, methanol, ethyl acetate, ethanol, and propanol, and isobutanol. For the procedure, we have three parts of procedure. The first one is the sample handling. The first step of the sample handling is the syringe was rinsed before filling it with the sample. The volume of the sample may be more than required volume. The syringe was gently tapped to remove air bubble because when we run this experiment, there have a few air bubbles in the syringe. The second step is the syringe was held vertically, needle up, and the plunger was pushed to the required volume at eye level. The tissue is used to remove excess sample. The second part of the procedure is the experimental. The first step of the experimental part is the instrument was switched on. Then the condition of the gas chromatography was set as the figure as the shown in the slide. Then the component sample and retention time was determined of each component individually. The standard mixture was injected and each component present was identified by comparing retention time of each component. Next, the unknown sample was injected and the component unknown was present was identified. Then, the column temperature was changed as follows, which is the initial and the final column temperature is 100 degrees Celsius. The standard mixture was injected and the effect of the reducing temperature on the retention time and the resolution of the components was commented. Then, the last one is the oven temperature was changed. The both of the initial and the final of oven temperature is 140 degrees Celsius. The standard mixture was injected and the effect of increasing temperature on the retention time and resolution of the component was commented. Then the last part of the procedure is the operation of the gas chromatography. The experiment was continued for operation of the gas chromatography. The figure on the slide is showing that the instrument that we use to run this experiment. The experiment that we use to run this experiment is the Aqilah 6890.
This is the result that we conclude from this experiment. For the discussion, chromatography is a method used to isolate and distinguish the components of a mixture. Based on the graph, peak 1, 2, and 6 are more polar that induce separation. The principle of separation of the light dissolved light principle refer to the polarity of the analyte and the immobilized liquid stationary phase. In addition, peak phi and peak C are excellent peak shapes and resolution. As it increases in Tr in all compounds, the height of the latter electing peaks is decreased and the widths are increased because they are more influenced by the lower temperature of the program used. Resolution is a test of how well the species are isolated.
As a conclusion, we managed to achieve the objective in this experiment to determine the retention time of N-butanol, which at 70 degrees Celsius, 100 degrees Celsius, and 140 degrees Celsius. The retention time for acetaldehyde is 1.25 minutes, for N-propanol is 6.75 minutes and 10.25 minutes for isobutanol, while retention time of 2-propanol at 70 degrees Celsius, 100 degrees Celsius, and 140 degrees Celsius are 6 minutes for ethyl acetate, methanol is 2 minutes, and ethanol is 3.63 minutes. From that, we managed to identify the unknown sample besides we are able to explain the effect of temperature on chromatogram, which temperature increased with the decreasing of retention time. The retention time also increased when the number of carbon is increased. Here are the resources that we use as a references in this experiment.
High-performance liquid chromatography, also known as HPLC, is a popular analytical technique that has been used for efficiently in separation, identification, and quantification for each constituent in a mixture. It is also known as an advanced technique of column liquid chromatography. HPLC is started by injecting the solute, which is analytes, onto the top of the column. Pumps will be used to pass pressurize the liquid solvent, including sample mixture, allowed to enter into a column that filled with the solid adsorbent materials at high pressure. The separation occurs when the analyte and mobile base are pumped through the column, which is it has a tiny particles that contain only 15 micrometer diameter, allowing the large surface area, which is a molecule, to adsorb, which is called as a stationary paste. It is connected with the detector and the computer in order to monitor the flow rate and detects the amount of the sample that present in a particular wavelength that called as chromatogram. Retention time is measured from the time at which the sample is injected, which the display shows the maximum peak height for that compound. Reverse phase partition chromatography is the most popular chromatography mode that used in a HPLC in order to separate neutral molecules in the solution on the basis of hydrophobicity, which is involved a non-polar stationary paste and a polar mobile paste.
Next, we proceed to the methodology in this experiment. First, caffeine standard solution. Preparing the stock solution, solution A, with the concentration of 1 mg per milliliter. First of all, 10 mg caffeine was weighed accurately into a 10 ml volumetric flask, and then it dissolved in the distilled water and was made up to volume with the distilled water. Second, preparing the working solution, solution B, with the concentration of 0.1 mg per milliliter. First of all, 1 milliliter of solution A was pipetted into a 10 milliliter volumetric flask, and then it was made up to volume with the distilled water. Second, for the sample preparation, about 10 milliliter of drink solution sample, including Coke, Pepsi, and 100 plus, was poured into a small beaker. A magnetic stir was used to remove any carbonation. 2 to 5 ml of a liquid was filtered through a 0.45 micrometer pore diameter membrane filter. to remove any particulate matter. 10 microliters solution B was injected into the HPLC to establish the retention time of caffeine. The peak area of caffeine was measured, and then 10 microliter of the prepared soft drink sample was injected into the HPLC instrument. And lastly, peak area corresponding of caffeine was measured by referring to its retention time.
Moving on to result analysis. On the left side of the slide, you can see the peak area of caffeine standard solution, and the retention time is 96 seconds. On the right side of the slide, you can see the peak area of caffeine graph for caffeine standard, Coke, Pepsi, and 100 plus. As you can see in table 2, is the table of retention time and peak area of caffeine in the standard and sample. Discussion. Caffeine is a stimulant drug that is found in coffee, tea, energy drinks, and some other soft drinks. The concentration of caffeine can be determined using HPLC. Now, caffeine was analyzed in water extract of coffee standard, Coke, Pepsi, and 100 plus samples. Based on the graph and the table of the retention time for caffeine standard was found to be 2 minutes or 96 seconds. The retention time is a measure of the time taken for a solute to pass through a chromatography column. It is calculated as the time from injection to detection. The retention time for a compound is not fixed as many factors can be influenced. It even is the same GC and column are used. This includes the gas flow rate. The longer retention times depends on the interaction of the analytes with the stationary phase. The stronger the interaction, the more will be of the interaction time. Now, the retention time for Coke and Pepsi were both 2 minutes, while 100 plus is 0.53 minutes. The peak area of caffeine for caffeine standard is 211,000. For Coke and Pepsi were both 1200,000, while 100 plus is 8,500. Now, to determine the amount of caffeine in soft drink samples is used by the following equation. The following equation are response factor is equal to the peak area of caffeine standard over the concentration of caffeine standard, and the concentration of caffeine in the unknown sample is equal to the peak area caffeine in sample over Rf. Now, extreme care is required to ensure repeatability and accuracy of results. Precaution exercise during preparation and handling of both of mobile phase are bound to ensure reproducibility of result run after run and save us from avoidable work stress. A few other precautions while handling the experiment would be to wear personal protective equipment such as lab coat, enclosed shoes, glove, safety glasses or goggles. And last but not least, do not allow the skin to come into contact with the HPLC solvent and do not breathe the fumes of these solvents.
In conclusion, the outcome of this experiment is appropriate. In addition, always ensure that mobile phase and sample filter are in good working condition, and the degas mobile phase avoid the introduction of an air bubble in order to obtain the best possible outcome.